Hello and welcome to the walking talking topic on circle theorems, question number 8 with me, Mr. Barton. Now, a very challenging question here, but that's no reason to leave it out. We can do this. It'll be fine. So 3 points A, B and C line the circumference of the circle. The tangent XAY touches the circle at point A. Find each of the following angles and give reasons, very important, for your answers. So C to B to O is that angle there. Now he's pretty tricky to get and you can't get him in one step unfortunately, but you can get him as long as you know the hardest of the circle theorems, the alternate segment theorem. And that says if you've got a tangent like we have here, meeting a chord like we have there with A to C, then the angle that the tangent and the chord makes is the same as the angle in the alternate segment. In this case, angle ABC. I explain this to my students by saying we've got a chord meeting a tangent. That angle is exactly the same as the angle at the top of the chord made by the triangle. So that entire angle round there. Now that's not the one we want, but it's certainly going to help us. So I'm going to say angle ABC is equal to 72 degrees. Reason, the alternate segment theorem. There we go. And now we've got that whole angle there is 72, but do we know this little bit? Well, we do, because we've got an angle that's 35 degrees, and the line O to A and the line O to B must be equal to each other because they're both radiuses of the same circle. So if that's 35, then that must also be 35 degrees too. So I'm going to write that down. Angle ABO equals 35 degrees, and I'm going to put here isosceles triangle. So now I'm laughing because I know my whole thing's 72. I know that my one side of it's 35. So angle C to B to O must be equal to 72 take 35 degrees, which, if my maths is right, and please don't get this wrong at this stage, I reckon that's 37 degrees. So I've got him there as 37 degrees. Now what about this? Angle B to C to A. Well, this isn't quite as bad as that one. B to C to A is there. And as soon as you start seeing something on a circumference, then I'd be thinking, is it one of those angles on angles at the centre jobs? And I think this is, because we've got ACB and we've got AOB. If I can work out the size of AOB, then I'm laughing. And I can, because again, I've got an isosceles triangle. I know he's 35 and he's 35, so I think that's going to come to 70. And if I do 180, take off my 35 and my 35. So 180 take off my 70, I'm going to get 110 degrees. So that's going to be 110 degrees. And all I've used there is angles in a triangle add to 180 degrees. And then finally, the angle at the centre is going to be double the angle at the circumference. So that is going to be 55 degrees. Let's write it down to make sure I get it. I've got... Oh, sorry, I should have put there that was angle AOB. And now to get angle ABC, then I'm going to do 110 divided by 2 equals 55 degrees. And just to get the final mark, let's write it down. Angle at centre is double the angle at the circumference. Done and dusted, 4 marks.